Okay, I only have 10 minutes before the staff meeting. So here we go quickly. What we're going to talk about today is we're going to talk about controlling the regulating urine formation. So regulating urine formation, in effect, is actually controlling blood volume and blood pressure. Because remember, they're really close. All your blood is going through the kidneys, and it's very important what happens in the kidneys because all your blood is going through there. So you're filtering out the blood and you're controlling the pH of the blood. You're controlling what's in the blood. You're pulling out those sugars. You're pulling out amino acids. If you don't do that, you'll be peeing. Your blood will have less sugars and amino acids. You're controlling how much hydrogen ions are going in, or how much hydrogen ions are going out. So you're controlling the pH, and you're also controlling salt content and water content. So you're controlling blood volume, and urine volume, and in effect blood volume, and therefore blood pressure. And that's where regulating urine formation comes in. So you've got a bunch of hormones that do this. The first one is ADH, antidiuretic hormone. And ADH works on the collecting duct. It's released in the hypothalamus by the pituitary gland. There's a picture of it there. There's the hypothalamus, pituitary gland. It's released into the blood, and it works on the collecting duct. Let's scroll. There we go. There's the collecting duct there. That's that last bit where water is being reabsorbed into the extracellular fluid, and then that water continues on into the blood vessels. So what happens is ADH makes the collecting duct, the proteins in the collecting duct, more open, activates more of those proteins. The walls of the collecting duct get more of those proteins working, and so what happens is more water can be pulled out and into the blood. Blood volume goes up, blood pressure goes up, urine becomes more concentrated. So urine concentration goes up, basically, and the volume of urine goes down. So you get dark pea-colored urine. It's not watery urine. That's what ADH does. Things like alcohol block the working of ADH. So folks who drink alcohol, they have to pee more often because their collecting duct is not reabsorbing all that water. That water is just going down the collecting duct into the renal pelvis, down the ureter, into the bladder, and you pee it out. You lose all that water. That alcohol makes you dehydrated that way. You are losing all that water. You're not reabsorbing that water. And so alcohol makes you dehydrated. The next hormone comes from the kidney. Well, it comes from the adrenal cortex, which sits on top of the kidney. It's like a thing on top of the kidney like this. There's a picture here somewhere. It's good to have things on the kidneys. Where can I find it? There it is. Adrenal gland. There we go. The adrenal gland makes aldosterone or aldosterone. It's released by the adrenal cortex. Again, blood pressure drops, and so in a kind of emergency sort of way, the adrenal cortex is an emergency gland in a way because it's right on the kidney, and all your blood goes through the kidneys. So when you release adrenaline, that comes from the adrenal cortex, and because there's a bear chasing you, it all goes right into your blood, right there at the adrenal gland. Anyways, so what aldosterone does is it increases the amount of sodium reabsorption at the distal convoluted tubule. Basically what that means is here you're pulling in more sodium. This is a distal convoluted tubule, this is a loop of Henle, but here you're pulling out more sodium out of the urine, and so what's happening is your blood is getting saltier. There, your blood is getting saltier. As a result, blood is saltier, it's hypertonic, water gets pulled out of the tissues into the blood. Blood volume goes up. It basically does the same thing as ADH. The effect is the same, especially here. More water will be pulled out. So what happens is there's an osmotic gradient into the blood, a stronger osmotic gradient into the blood because the blood is saltier, because this area is saltier, so the water is pulled out more. There's more more water. It does the same, basically the effect is the same as ADH. Blood becomes hypertonic, which leads to greater reabsorption of water. Urine becomes more concentrated. Blood pressure increases. Okay, same thing as ADH, essentially, but it's working in a different place. It's not working on the convoluted tubule. It's not working on the collecting duct like ADH. It's working on the convoluted tubule. Okay, and then you'll notice that these are all increasing blood pressure. You have two hormones to increase blood pressure because blood pressure is really important because you need blood pressure to get oxygen into your brain. So we have hormones. So if your blood pressure drops, ooh, your body is ready to get that blood pressure back up. You bet. Not a lot of hormones to lower blood pressure, except this one, atrial natriuretic hormone, ANH. So it's released in the atria of the heart. Remember the atria of the heart? Remember when we did the heart, whenever we did it long years ago? The atria, if they feel that they're getting stretched too much, blood volume is too high, there's too much blood pressure is too high, blood volume is too high, the atria have special tissues that will release ANH. And it's to counteract high blood pressure, because here the blood pressure is so high it's becoming dangerous. And what happens is the afferent arteriole dilates, the efferent arteriole constricts. What does that mean? Okay, well, we have to find them. Oh, this is not a bad image. So here's the glomerulus. The afferent arteriole leads to the glomerulus. The efferent arteriole leads away. That's where all those exchanges happen. So the afferent arteriole dilates. So it becomes bigger. The efferent arteriole becomes smaller. It constricts. So now blood is restricted from going in here, but there's more blood shooting in here. So what happens, more of the plasma, more water, basically, is forced out of the glomerulus. Basically, the pressure goes up in the glomerulus because that efferent arteriole is closed now, but there's more water coming in. Where's that water going to go? Where's that blood plasma going to go? It's going to go out of the glomerular capillaries into the Bowman's capsule, into the urine. So the more water is being forced out of the blood. So blood volume goes down, blood pressure goes down, the atria of the heart are saved. Okay? That's ANH. There's some of these diuretics. I already talked about alcohol, which inhibits ADH secretion, so then less water is reabsorbed and your volume of urine increases, your blood volume decreases, you basically are getting dehydrated. And caffeine is another one. Caffeine does all kinds of stuff. It increases filtration pressure. So it basically kind of does what ANH does, but not really. But you have more water is going into the urine with caffeine, and your blood volume goes down. Blood pressure blood pressure is going up because caffeine does other things, but caffeine dehydrates you that way by sending more water out into the pee. So you pee more often when you drink caffeine. When you drink coffee, you are stimulated to pee, basically, more often. Okay, so that's it for now. I have to go to a staff meeting. Quiz on this tomorrow. Study the notes, study what I yammered on about in these videos, and you will do great. You will do fine. It's online. You will have your books and things with you. You guys always you'll do well. Okay, great.